Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 9 students and the topic of discussion is statistics. In this video, we will be focusing on the solutions to the NCERT problems. A survey conducted by an organization for the cause of illness and death among the women between the ages 15 and 44 years worldwide found the following figures in percentage. This is the female fatality rate due to various causes given here. We need to represent the information given above graphically and which condition is the major cause of women's ill health and death worldwide. So which is the major cause? Immediately we can say that which is the maximum number here. It corresponds to the first row, which is reproductive health condition. So reproductive health condition is the major cause of women's ill health and death worldwide. So this is the answer for the second part. Now let us do the first part. We have to represent this information in this table in a graph form. So what type of data this is? When the x-axis or the causes is given in verbal form and the y-axis is given in data form or numerical form, this is called as the categorical data. So we use a bar chart to process a categorical data. This is categories. These are numerical values. So a bar chart will be appropriate. So on the x-axis we put the causes, which are these are the causes, and y-axis the length of this bar chart or the length of the bars correspond to these values. So we see that maximum value is 31.8. So we plot here from 0 to 50, we put it as scale. And the length of the bar is proportional to these values. The width of the bars are constant for all cases. Only length will vary corresponding to these values. The second problem, the following data on the number of girls to the nearest 10 per 1000 boys in different sections of Indian society is given below. This is the section, different categories of data are given, and y-axis contains the numerical value. So again we can use a bar chart to plot this. So represent the information above by a bar graph. In the classroom, discuss what conclusions can be arrived at from the graph. So we observe that the minimum value is 910 and the maximum value is 970. So on the y-axis, we will not start from 0 but from 900, say 900 to 1000. That will be more appropriate. So here we have put the section. These are the section SC, ST, backward districts, rural, urban. So we have put different x-axis contain different categories of data and y-axis contains the numerical data given here, which is number of girls per 1000 boys. So we put a break line here because it is starting from 900 and not from 0. So that's why on the y-axis you can see a break line. And the length of the bar is proportional to these values. But the width of the bars are constant. So what other conclusions can be drawn from this data? The number of girls per 1000 boys represented in the graph is maximum for scheduled tribes. So this is the maximum value 970. The number of girls per 1000 boys represented in the graph is lowest for urban. So this is lowest for urban. The number of girls per 1000 boys are higher in rural areas than in urban. This value is more than this. These are some of the conclusions that can be drawn from this graph. Given below are the seats won by different political parties in the polling outcome of a state assembly elections. These are the names of the political parties A to F. And these are the seats won. We need to again draw a bar graph to represent these results. Which political party won the maximum number of seats? So part 2 is very easy. So we see the maximum value here, which is 75. So political party A has won the maximum number of seats. This is the answer for part 2. Again, this is a categorical data. The x-axis will contain the political party. The y-axis will contain the seats one. Again, we see the maximum value is 75. So we can draw a bar graph on y-axis varying from 0 to 100. We can draw like this. This A political party A, B, C, D, E, F, and their widths are same, constant, but their length is proportional to the data given. The length of 40 leaves of a plant are measured correct to 1 millimeter and obtained data is represented in the following table. So this is the table given. We need to draw a histogram to represent the given data. We need to also make the class interval continuous. Now, so far we had been talking of the word bar graph. What is histogram? Histogram means when the x-axis contains numerical data. Previously, we have seen that the x-axis was containing categorical data. Some verbal names were there, but here numerical values are there. So when x and y are both numerical values, the graph becomes a histogram. Otherwise, it is called a bar graph. Also, is there any other suitable graphical representation for the data? We need to explain. And is it correct to conclude that the maximum number of leaves are 153 centimeter long? And we need to explain that. So how do we make this as continuous? We see that this particular upper value of class interval is 126, but the next value is starting from 127. So the class intervals are not continuous. So how do we make it continuous? We can subtract this value 127 and 126 and get a difference as 1. And we divide it by 2. So that 1 divided by 2 will be 0.5. So this value will increase by 0.5 and this value will reduce by 0.5. So this become 126.5, this become 126.5. Hence it becomes continuous. So this is what we have done here. We have made the class intervals now continuous. This is repeated for all class intervals. Frequency remain as it is. Now we can draw the histogram, where on the x-axis it will be length and on the y-axis will be this frequency or the number of leaves. So how do we proceed to draw this? We use constant widths because we see that the class intervals are having constant width. So we draw with constant width. We start from 170.5 and end with 180.5. Since we are not starting from 0, we put a break line here. Now the second part is there any other suitable graphical representation of the same data? Yes, we can use the frequency polygon as well. Then is it correct to conclude that the maximum number of leaves are 153 millimeter long? Let us see here. So the maximum number of leaves is in this data 144.5 and 153.5. But they are the maximum number of leaves in this class interval, but it does not mean that the maximum number of leaves is 153 because 170 to 180 also there are 2 leaves. So maximum number or the maximum value of the leaf could be around 180. So we cannot conclude. Is it correct to conclude? No, it is not proper to conclude that the maximum number of leaves are 153 long. And one more interesting thing is how to find the length of this bar diagram. The length is proportional to the frequency here. The same value. For example, 144.5 to 153.5, there are 12 leaves. So we on the y-axis is the frequency. We mark here 12 and the widths are constant as per the problem. The following table gives the lifetimes of 400 neon lamps. Represent the given information with the help of a histogram. And how many lamps have a lifetime of more than 700 hours? So this is the lifetime in hours. We see that the distribution is continuous. It is ending at 800, beginning at 800. So it is a continuous distribution. And also the class width is same of 100. 400 minus 300 is 100. So all the class widths are same. This is the frequency. So very easy to draw again this. We start from the value 300 with a break line because it is not starting from 0. So we are putting a break line. So we mark these values 300, 400, 500. We see that the class widths are same. The lengths are proportional to this. For example, first value will be 14. So we take a 14. For a constant width, we draw this bar or the histogram. Similarly, we repeat for the other class intervals. Also, we need to find how many bulbs have a value of more than 700 hours. So more than 700 hours means these three class intervals we have to see. And these are the frequencies. So we need to add up this 74 plus 62 plus 48, which is 184 lamps. So 184 lamps have a lifetime of more than 700 hours. The following table gives the distribution of students of two sections according to the marks obtained by them. So these are the frequencies of section A, these are the class intervals, and these are the marks for section B. These are the frequency, these are the marks. Again, we need to represent these marks of students using frequency polygon. Till now we had been using a bar graph and histograms. Now we need to represent using frequency polygons. From the two polygons, compare the performance of two sections. So what shall we do? So for finding the frequency polygon, we need x-axis as the class mark. So we add these two numbers and divide by 2, or the central value of this is 5. 10 and 20 divided by 2 is 15, and so on. And these are the frequencies which is already given. Similarly, repeat this for the section B. Now we plot for section A first. This will be x-axis and this will be y-axis. So 5 and 3. So 5 is given here. So 3 is value here. Similarly 15 and 9. 15 is here and 9 is here. So we plot these different points and join them with, say, a blue dotted line. Similarly, we can repeat for section B with a dotted red line. So what we can observe? It can be observed that the performance of student of section A is better than the student of section B, as section A mark shows more students securing marks between class interval 40, 50 and 30, 40. So this side we see that section A has performed better. So this frequency polygon helps in visualizing the data very appropriately. The runs scored by two teams A and B on the first 60 balls in a cricket match are given below. So these are the runs scored. Represent the data both the teams on the same graph by frequency polygon. So we have to use a frequency polygon to draw this. First, make the class intervals continuous. Again, we see that this upper value of the class interval is 6 and here it is starting from 7, so they are not continuous. So how to make it continuous? We have to subtract 7 minus 6, which is 1, divided by 2 is 0.5. So this value will increase upper value by 0.5 and lower value will subtract 0.5 and make this class intervals as continuous. So we have made it continuous here. And these are the class marks. Class marks are the central value of this. So how do you find central value? Add these two values and divide it by 2. For example, 0.5 plus 6.5 is 7, divided by 2 is 3.5. and these are the frequency values given already in the problem. So we can easily draw the frequency polygon. This will be x-axis for team A and y-axis for team A will be these values. So we'll plot 3.5 and 2, 9.5 and 1. So these are plotted with these blue lines. These points represents the data values of the pair, x and y pair. Then we join with the dots. This is for team A. Similarly, team B, the x value will remain same as this, 3.5, 9.5, and the corresponding y values will be 5, 6, 2 and so on. So this will be plotted by the red curve here to distinguish between the two teams. So this is the frequency polygon. A random survey of the number of children of various age groups playing in the park is given below. This is the age and this is the corresponding number of children in that age group. Draw a histogram to represent the above data. Let us observe the data. Here it is slightly different from the previous problem. For example, here we see what is the class width. 10 minus 7 is 3. Here 7 minus 5 is 2. Here 15 minus 10 is 5. So the class width is not the same. And this is the frequency, that is no issue. So how do we approach for problems in which class width is not same? So first we find the width. So width is how much? Upper value minus lower value. So 2 minus 1 is 1, 3 minus 2 is 1, 5 minus 3 is 2, 7 minus 5 is 2, 10 minus 7 is 3 and so on. So whenever the class width is not same, so far we had been doing for the same class width, but here class widths are not same. So how do you find the length of the rectangle? Previously we were taking exactly these values as the length of the rectangle, but since class width is not same, it is not proper to use these values directly. So we need to modify these values to get the appropriate length of the rectangle. So how do we find the length of the rectangle? Length of rectangle is given by frequency by the width, corresponding widths. So 5 by 1, 3 by 1, 6 by 2, 12 by 2, 9 by 3, 10 by 5, 4 by 2. And we also see that we are multiplying by a number 1. Why? 1 is the minimum value of the width. So we need to also find the minimum value of the width is 1 here. And we need to multiply this frequency divided by width into the minimum value of the width. So this is the length of the rectangle. Now we need to plot the class mark with this length of the rectangle. Agreed? So from 1 to 2, length of the rectangle is 5. Similarly 2 to 3. And we see that various widths will come now because the problem is given such that only thing is length of the rectangle is modified by these values and not by these values. 100 surnames were randomly picked up from a local telephone directory and a frequency distribution of the number of letters in the English alphabet in the surname was found as below. Number of letters is this, number of surnames is this. We need to draw a histogram to depict the information. Write the class interval in which the maximum number of surname lies. So maximum number of surname is 44, which lies in the class interval 6 to 8. So now we need to draw the histogram. Let us observe the data. Again we see that the class width is not uniform. 4 minus 1 is 3, 6 minus 4 is 2, 12 minus 8 is 4, 20 minus 8, 12 is 8. So the class width is not small. So we have to make the length of the rectangles not these values but by the previous formula which we discussed. So this is the number of letters. This is the number of surnames which is given. Now the width of the class we need to find. 4 minus 1 3, 6 minus 4 2, 12 minus 8 4 and so on. Now how do we find the length of rectangle? The length of rectangle is given by frequency divided by the width into the minimum value of the width. Minimum value of the width is 2. This will be 6 divided by 3 into 2, 30 divided by 2 into 2, 44 divided by 2 into 2, 16 divided by 4 into 2, 4 divided by 8 into 2. So this will be the corresponding length of rectangle. So we draw here. This will be the number of leaves here. This by this class interval, and the frequency or the length of rectangle is now given by these number. If the class width was same, then we use directly these values. Friends, with this we conclude this video. I hope you liked my video. Please subscribe my channel and give a thumbs up to it so that in future videos can be released to you instantly. Thank you very much, friends.